All right, so today we're going to be, you knew this day was coming, we're going to be graphing sine and cosine. So that's what the essential question is. How do I graph sine? How do I graph cosine? There are a bunch of terms that we need to define because these are actually very different functions than we're used to. So in your own graph paper, how about you go ahead and draw this coordinate plane, and notice that I've kind of drawn it longwise. So yeah, just draw it longwise for yourself, and I'll tell you how we're going to label some things. So first of all, we need to pick some points to plug in, and this is going to be a little bit tricky for us because plugging in sine of 1, like, is it 1 degrees? Is it 1 radians? Do I even know what sine of 1 is easily? Like, we need to make some decisions here. So decision number 1, well, let me set up our xy table. So xy. Our first decision is that we're going to be working in terms of radians. And you might be annoyed by this. Typically, you're used to working in degrees. Degrees is just how you've thought of angles in the past. But basically, every time mathematicians graph these things, and every time you see these graphed in the real world, we do it with radians, and the reason is because they're actually a little bit easier to convert real-world problems into radians if we're using it to model specific things, which we'll talk about later on. So radians, first of all. Second of all is what x's are good to plug in. Like, if I put an x of 0, do I know what sine of 0 is? Do I know that? Well, let's take a look at the unit circle. The unit circle is our friend here because we have all of these angles that we know sine for. Remember, sine, we're going to be looking at the y. So if I have a sine of 0, what's the y coordinate? Well, it's 0. Okay, nice. And I'm going to be referring a lot to the unit circle today, so I hope that you have the unit circle in front of you because then I won't have to switch back and forth. So sine of 0 is 0. Now, we could plug in something like pi over 6. Sine of pi over 6, if you look at your unit circle, is 1/2. However, just because I know where we're going with this, let's have our next value be pi over 4, just to kind of see what's happening. Sine of pi over 4 is root 2 over 2, but since we're graphing this, let's get it as a decimal. The square root of 2 divided by 2 happens to be about 0.7. So we'll just say that root 2 over 2 is 0.7. That's rounded a lot, but it's close enough. Then let's go to pi over 2. And we know the sine is 1. So notice that we're kind of following a pattern of going every pi over 4. So let's go to 3 pi over 4 next. That would be, again, 0.7. Let's go to pi next. Here sine is 0 again. And then notice what's happening. So we've graphed all positive signs so far. We've done 0, we've done pi over 4, we've done pi over 2, and so on. But now we're moving into an area where sine starts to be negative. Interesting. So when we graph, the sine of 5 pi over 4 is negative 0.7. The sine of 3 pi over 2 is negative 1. And let's just finish it off. We'll make it the whole way around the unit circle. Next would be 7 pi over 4. That's negative 0.7. And then 2 pi. Notice we've kind of made one complete trip around the unit circle now. If you have it in front of you, you can see it. We've made one complete trip around the unit circle. 2 pi is 0. So, okay, how am I actually supposed to graph these values? First of all, notice that I'm only ever getting up to 1 and down to negative 1. So let's say 1 is right here, negative 1 is right here. The next thing is that I want to work in terms of like pi over 2 sort of. So here's how we're going to do it. Every one of these lines is going to be pi over 2. So pi over 2, pi, 3 pi over 2, and then 2 pi. So basically every grid line is an extra pi over 2. Because that's kind of when we hit the big values. So let's look at what's happening here. Let's just plot these points. Over 0, 0. Now, isn't it true that pi over 4 is halfway between pi over 2, and 0. Do you see the pattern going on here? Like basically every one that I put an arrow next to, these are the ones right on the grid lines. The over 4 ones, like this one, this one, this one, these will be in between the grid lines. Okay, so over pi over 4 up 0.7, that's right about there. Actually, it'd be right about here. Okay, and then over pi over 2 up 1, over 3 pi over 4 up 0.7, then I go back to 0, then I go down to negative 0.7, then negative 1, then negative 0.7, and then 0. So you have this nice, like, we actually call it a sinusoidal curve. Obviously, that's getting its name from sine. And this is going to make a wave. Interesting. It goes up and then it comes back down. But the question is, what happens as it keeps going this way? Well, let's just think about this for a second. Isn't it true that after I get past 2 pi, I'm starting to reach coterminal angles? So in other words, from here to here, this represents one complete loop around the unit circle. Now that I've gotten to here, I'm making one complete loop plus an extra 45 degrees or pi over 4, which means this value is equal to this value, since these are coterminal angles. Next is going to be, what's the next one? 5 pi over 2. I'm just reducing in my head. And that would be if I made one complete loop and then am going up to a 90-degree angle. So that would be 1. So do you see how the pattern's repeating? And the reason the pattern is repeating is because I'm going back around the unit circle. Likewise, if we go in a negative direction, isn't it true that if I go negative pi over 4, this is coterminal to this one? So because of all these coterminal angles, basically the pattern is going to repeat. So I'm going to go up to 1, I'm going to go back to 0, I'm going to go down to negative 1, I'm going to go back to 0. This pattern is repeating, and it will repeat on and on forever and ever. So let's draw an arrow. It will also repeat in the other direction. And again, the reason is because I'm just going around and around the unit circle. I'm hitting all of these coterminal angles. Okay? Now let's just talk about cosine real quick. Let's go down. For cosine, let's just plug in the same values, except here's something that I want you to notice. Did you notice how here we met the maximum and the minimum at what we call the quadrantal angles? In other words, these are those nice 90-degree angles. So for cosine, instead of doing the pi over 4, let's just worry about the quadrantal angles, just the 90-degree angles, okay? And let's see what our pattern is. Now, this time when I look on the unit circle, I'm looking for cosine, and remember that cosine gives me the x value. So just a quick sketch. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then I'm repeating the pattern. Here's 2 pi, then I'll go to this one again, then I'll go to this one again, then I'll go to this one again. On and on around the circle, making a sinusoidal curve. So let's actually look back at our chart. According to the unit circle, cosine of 0 equals 1. It's a useful fact to remember. Cosine of 0 equals 1. Cosine of pi over 2 is 0. Pi is negative 1. 3 pi over 2 is 0. 2 pi gets me to 1. And if we keep going around the unit circle, we know this pattern is going to continue on and on, likewise in the negative direction. So let's graph these points. Again, I'm going to make this 1. I'm going to make this negative 1. We have pi over 2. We have pi. We have 3 pi over 2. And we have 2 pi. That's the scale of my x-axis. And let's graph them. Here's 1, 0, negative 1, 0, 1. And we know that this pattern continues on and on. Notice that this is also making a wave. It's just that instead of the wave starting in the middle, like the sine did, the wave is kind of starting at the top. Interesting. Okay, so I wanted to show you real quick how sine and cosine look next to each other because it's actually really cool. Take a look here. My sine is my green graph. Notice how it starts right at the origin and then it makes its wave. The cosine is actually making exactly the same wave except it's starting up at 1 and then it's kind of, we would call this a phase shift. It's kind of like shifted over from sine. The reason it makes sense that these are following exactly the same pattern is because all we're doing is going around the unit circle. Very neat. Now, I need to define a couple words for you. We'll look at just the sine graph to define these words because the cosine graph, since remember it looks very similar to the sine graph, is going to basically have the same words. First of all, the maximum. We're hitting a maximum here, we're hitting a maximum here, we're hitting a maximum here. That maximum is always 1, right? The minimum. We're hitting a minimum here and here and here. That minimum is -1 in this case, -1. Okay, now if you notice, this is kind of symmetrical-ish around this center line. Do you see how the graph keeps passing through 0? It's always passing through 0. So we have this center line going through the middle in the graph. Notice it's exactly the same distance up to the top as it is down to the bottom. It's 1 each time. And we call this distance from the center line up to the top the amplitude. So in this case, the amplitude is also 1. Why? Because from the center line down to the minimum, it's 1. Also from the center line up to the top, it's 1. So the amplitude is 1. And amplitude is something you may have learned about before with like radio waves. All right, the last thing we need to define is the period, and the period means how often the graph repeats, or in other words, how long does it take it to repeat. So let's think about where we started here, and let me clear up the graph a bit. We started making our points right here. We started at 0, 0, then we went up to 1, down to 0, down to 1, up to 0, and that's where the pattern repeated, okay? After that, I did the exact same thing. Up, down, down, up. So the period lasts from here to here, and if you think about it, this is where we went once around the unit circle. Remember how I said from here to the 2 pi, we went once around the unit circle? So this is one period, one trip around the unit circle. How long is it? The same distance around the unit circle, 2 pi. So in this case, the period equals 2 pi. It makes sense if you look at the graph, because that's how often it takes the pattern to repeat. It makes sense if you think about a unit circle, because the reason the pattern repeats is because I went the whole way around the unit circle. All right, we'll get more in depth about how to transform these things in class. Hint, it's the same as it always works. But otherwise, thanks for watching.